What if a cosmic mystery was unfolding in our skies, right now? Not in the history books, but tonight. 3 minutes ago, the alert started firing. A new object, C/2025 V1, just appeared, drifting between Earth and a bizarre interstellar visitor. Both are shining with an unnatural, baffling brightness, yet neither has a tail. This isn't just an oddity. It's a direct challenge to the fundamental physics of comets. This defies everything we think we know about how these objects behave under the sun's influence. Is it a prelude to a collision, a rare alignment, or something else entirely? Let's delve into it. Discovery Night. How does a discovery that stuns the world begin? Not with a massive government array, but with one man and his homemade telescope. On the night of November 2, 2025, veteran comet hunter Gennady Borisov was at his private Margot observatory in Crimea. He spotted an unfamiliar blur moving against the stars. Borisov is no amateur. His name carries weight. In 2019, he became a legend for discovering 2I/Borisov, the first confirmed interstellar comet. A feat that cemented his place in astronomical history. Now, 6 years later, his sharp eyes and custom optics caught another cosmic outlier. He quickly calculated its position, its bizarrely bright magnitude of 12.1, and noted the critical detail: a sharp, distinct coma nearly half an arc-minute across, but absolutely no sign of a tail. This combination of features is profoundly strange. He immediately fired off the report to the Central Bureau for Astronomical Telegrams, the official clearinghouse for these discoveries. The entire astronomical world was about to be shaken awake by one man's relentless and solitary watch of the night sky. Global alert. How fast can the world react to a single discovery? In the age of connected astronomy, the answer is instantly. Once Gennady Borisov's alert hit the network, it was a global race against time. The provisional tag assigned to the object was a signal to astronomers everywhere that something unusual was afoot. Observatories from the Canary Islands to Japan and Ukraine swiveled their domes to confirm the find, their automated systems locking onto the new coordinates. A flood of astrometric data, precise measurements of position, poured into official databases and online forums. The consensus, led by analysts like dynamicist Quanji Ye, who helps verify such discoveries, was immediate and startling. Almost every team saw the same thing Borisov did: a condensed, intensely bright coma with no tail. Out of the first 10 reports, only 2 hinted at a faint, inconsistent wisp that was quickly debated as a possible imaging artifact or background noise. By November 3, the object was official: C/2025 V1 Borisov. The alert now became a global campaign, a collaborative effort with the world's telescopes turning to this strange new visitor to unlock its secrets before it faded. Rapid brightening. What if an object appeared out of nowhere and became 100 times brighter in just 5 days? That's the anomaly that turned C/2025 V1 from a curiosity into a global obsession. After the discovery, astronomers dug into archival data from automated sky surveys. They found the first traces of the object on survey frames from the Palomar Observatory, dated October 29, 2025. Back then, it was a barely there smudge at magnitude 17.5, visible only to the largest professional telescopes. But by the time Borisov spotted it, it had surged to magnitude 12.1. This 100-fold increase in brightness is almost unheard of, and sent a shockwave through the amateur astronomy community. This rapid surge, analyzed by comet light curve experts like Carl Battams, could suggest a sudden fragmentation event or the exposure of a massive fresh patch of subsurface ice to sunlight. It meant the object was now within reach of modest backyard telescopes, sparking a frenzy. Confirmation images poured in from Japan, Ukraine, and Russia, all showing the same tailless, condensed coma. The nightly exchange of data became a ritual, with observers worldwide confirming its stunning and completely unpredicted rise. 3 paths. To grasp what's happening up there, you can't just look at a flat sky map, you have to see it in 3 dimensions. In the pre-dawn hours of November 7, 2025, we have 3 comets in play: C/2025 V1 Borisov, the Interstellar Visitor 3 I/Atlas, and C/2025 K1 Atlas. From our perspective on Earth, V1 Borisov and 3I/Atlas appear clustered together in the constellation Virgo. but celestial mechanics expert Paul Kodas confirms this is a grand illusion of parallax. V1 Borisov is the closest to us, at about half the distance from the Earth to the Sun, crossing our orbital plane. 3I/Atlas, however, is much farther out, well beyond the orbit of Mars on a hyperbolic escape trajectory that will fling it out of our solar system forever. They are separated by tens of millions of kilometers, a vast gulf of empty space. Meanwhile, the third comet, K1 Atlas, is on a completely different track in the constellation Leo. The geometry creates a brief, 3-day window where all three are visible, a fluke of perspective. 3 objects, 3 distinct orbits, and a temporary alignment that exists only in our line of sight, not in physical space. Dawn Watch. Want to see this cosmic drama for yourself? Here's your guide for the early November dawn. The main stage is in the constellation Virgo, rising in the southeast about 2 hours before sunrise. This is where you'll find our 2 headline acts. The newcomer, C/2025 V1 Borisov, is holding steady around magnitude 13. Anyone with an 8-inch telescope or larger under dark skies can spot its soft, round tailless glow. Use averted vision, looking slightly to the side of the object, to make its faint light pop. Just a few degrees away is the brighter but equally mysterious 3I/Atlas. It hovers around magnitude 10, also stubbornly tailless. For skywatchers like science communicator Bob King, this is a unique challenge, spotting 2 comets that break all the rules. But don't forget the third player. Over in the constellation Leo, you'll find C/2025 K1 Atlas. It's fainter, but it's a favorite for photographers because it has a stunning golden yellow tail, a stark contrast to the other 2. This fleeting alignment, from November 6th to 8th, is a rare opportunity to witness 3 completely different cometary behaviors in one morning. Missing tails. Why would a comet, especially one that's brightening rapidly, not have a tail? This is the core puzzle puzzling astronomers, and the answer may lie in heavy dust. According to cometary dust physicist Matthew Knight, it's all about a value called the beta parameter, which measures how strongly sunlight pushes on dust particles via radiation pressure. For small, lightweight grains, the momentum from photons easily blows them away from the comet's nucleus to form a long, classic tail. But the data from both V1 Borisov and 3I/Atlas suggests they are ejecting large, heavy, refractory grains of dust, perhaps a mix of ice and carbon-rich material. For these heavier particles, the beta value is low. Sunlight simply can't push them hard enough or fast enough to escape the nucleus's weak gravity. Instead of streaming away to form a tail, they just linger in a dense, compact cloud around the nucleus, forming what is called a coma-only morphology. This creates a bright, intensely concentrated head that outshines any hint of a faint tail. It's a perfect storm of physics that challenges our textbook image of what a comet should look like. Brightness puzzle. There's another mystery brewing, and it's centered on the interstellar visitor, 3I Atlas. This object isn't just tailless, its brightness is completely off the charts. Based on its distance and trajectory, standard models predicted it should be a faint magnitude 11.2. However, real-time photometric measurements from early November place it at a stunning magnitude 9.8. That 1.4 magnitude gap means it is nearly 4 times brighter than it has any right to be. Planetary scientist Karen Meach, who specializes in these distant and often bizarre objects, notes this isn't from a sudden outburst. The coma remains stable and compact. So what's going on? Scientists have scoured the orbital data for non-gravitational forces, the tiny rocket-like pushes from sublimating ice that can alter an orbit. So far, nothing significant has been found. The leading theory points to its composition, a possible mix of less volatile materials that are creating an unusually dense, highly reflective coma. For now, 3I Atlas's anomalous brightness is one of the most intriguing puzzles in the sky. Waiting for images. Amateur astronomers have done incredible work, but to solve the tail mystery, we really need eyes in space. The problem is, we're kind of stuck in a data bottleneck. China's Tianwen probe, which is currently orbiting Mars, released a short, low-resolution video clip of V1 Borisov. It confirmed the bright coma, sure, but it offered no new details, leaving some key questions totally unanswered. Meanwhile, hopes for a clearer view from NASA's Mars Reconnaissance Orbiter and its high-powered high-rise camera have, so far, been met with silence. JPL says it's about mission priorities and the need for optimal geometry, but honestly, the lack of updates is pretty frustrating. Louder still are the calls for observation time on the Hubble and James Webb Space Telescopes. Multiple urgent target of opportunity proposals have been submitted by teams led by astronomers like David Jewett to get those high-resolution images. Only space telescopes, operating above our atmosphere's blur, can resolve the fine structures around the nucleus that could finally settle the debate. The answers are just out of reach, locked behind the slow-moving gears of institutional review and data release protocols.
Solar storms.
Just to make things a little more interesting, the sun has been throwing a tantrum lately. A series of powerful solar storms have erupted, blasting the inner solar system with charged particles and intense radiation. Normally, this is great news for comet watchers. An event like this, a coronal mass ejection, should dramatically interact with a comet's coma. It typically lights up the ionized gas to form a distinct ion tail, often causing it to ripple or even disconnect entirely. Solar physicist Geraint Jones notes this provides a perfect natural experiment to probe the comet's makeup, yet, both C-2025 V1 Borisov and 3I Atlas have completely ignored the solar rage. Observers have reported no major changes, no sudden tail formation, no outbursts, and no shifts in coma structure. Their lack of response is, frankly, pretty bizarre. It suggests their comas are uniquely resilient, maybe shielded by a localized magnetic field, or composed of materials that just don't react to the solar wind's plasma. As the storms continue, every astronomer is glued to their screen, watching for any sign of a delayed reaction from these two stubborn cosmic mysteries.
Testing predictions.
When data is scarce and anomalies are plentiful, speculation tends to run wild. Some have even floated the idea that C-2025 V1 is a dispatch from 3I Atlas. While this is definitely in the realm of what if, it creates clear, testable predictions that skeptical scientists like Avi Loeb argue we should watch for. First, any sudden, unexplained changes in V1's trajectory, a non-ballistic movement, or any non-gravitational acceleration would be a massive red flag. Second, a fragmentation event that doesn't match known cometary physics would be telling. Third, any abrupt and coordinated changes in the brightness or morphology of both objects would be highly suspicious. And finally, the ultimate smoking gun, any kind of unexplained structured narrowband radio signals. So far, a review of all available data shows absolutely none of these have been observed. The data shows a stable orbit and a stable coma for both objects. Until a real anomaly appears in the daily logs, the best approach is to track the predictions, compare them to the evidence, and just let the data decide. So, here we stand, at the edge of a new cosmic puzzle. Two bizarre, bright and tailless objects are crossing our skies, defying our models and challenging our understanding of the universe in real time. This isn't just about comets, it's about the fundamental processes that build solar systems, both ours and those countless light years away. As solar storms continue to lash them with no effect, and our best telescopes wait for a green light, the mystery only deepens. This story is a powerful reminder that discovery is no longer a rare event. It's a relentless nightly process, and the cosmos is far from done surprising us. What we learn in the next few days could change the textbooks forever, proving once again that the universe is always more strange and wonderful than we can imagine. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Until next time, keep looking up. Thanks for watching Sci and Why.